Okay, here we go with another beautiful day. So, yeah, General Jargon was vindicated. I might be a missionary kid from the Amazon, but if some of the things I say are true. And so we have a scientist confirming the fact right now. So let's go to the video. Put myself over here. Go over here, YouTubies. There we go. Make it bigger. That's not bigger. Bigger. Yeah, okay. All right. So check out what this scientist is saying, keeping in mind everything I've been saying about time dilation and distance dilation, or the changing of the measure of time and the changing of the measure of distance and its implications. Watch him say almost word for word exactly what I've been trying to tell everybody.
Time is important, and so let's call it the time scale.
What if everything you've been told about the expanding universe is wrong? What if the acceleration we see in the cosmos that was awarded with the Nobel Prize by two of my past guests, Adam Rees and Brian Schmidt, is nothing but a cosmic illusion? What if it's a trick of time itself?
We're used to thinking about there is a single age of the universe and that's all there is. But
okay, see right there? Right off the bat, a single age of the universe. No, there is no single age of the universe. That's what I've been trying to tell people. And there you go. They got a vindication from a scientist. And he's going to explain it mathematically all the way through. We're not going to watch the whole thing because it's very, very long. I didn't even finish watching the whole thing yet. But check it out. Check it out what he's saying. Now listen carefully.
Actually, there is a relativity of cosmological time that is there in the structure of Einstein's theory.
This is for pseudo cosmic stage. Today, we're going to confront the very physicist that has stood by this claim and made these claims for more than a decade now. What's the cost of believing in the wrong universe? David, your model suggests that time runs faster in cosmic voids and that this differential clock rate.
Did you hear that? Time runs faster in cosmic voids. Not only that, but distance is expanded in cosmic voids too, which both of them contribute to making causation faster in the void of space outside of galaxies.
Explains the illusion of why we think the universe is accelerating. But voids don't just affect clocks, they affect photons as well. And
so this not only affects time or the age of the universe, it affects the so-called acceleration. And he's going to go through mathematically and explain the whole thing. The supposed acceleration, when it's not actually accelerating, it's just that as you leave a galaxy, light is redshifted. As you go back, if you enter into a galaxy or go into another galaxy, light is blue shifted. Everything being equal, it'll be red shifted and blue shifted back to its original spectrum. But depending on the mass of the galaxy too. Depends a lot on the mass of the galaxy and how far it is too, because how far it is going to make a difference too, because that's like the accumulation of all the galaxies against one little universe or galaxy that we live in, orbiting the sun in the Milky Way galaxy.
Interest being in Southern California is not just from Hollywood movie stars who may want to move out of voids to slow the aging process down, but I want to know, if this illusion is real, why doesn't it show up before? Why didn't it show up in the CMB data or in baryon acoustic data before now, or in gravitational lensing data, which probe the same geometry of time? Have you really uncovered a new
The gravitational lensing is right there. It's right there in the data, in the gravitational lensing. It's the exact same thing. A lens consists of a place where light is slowed down in the center more than it's slowed down away from the center. That is a definition of a lens. So it's right in there in the geometry of the lens.
New layer of relativity, or are we just misreading our own stopwatches?
Well, I think we've been misreading things for a long time. So the thing is, you can interpret that same data in different ways. It's fitting a model to the data, and dark energy, etc. That is a stand-in prop, something that we don't understand. And my view is that we really have to understand the foundations, and that's why I've been going back to foundations.
Yeah, dark matter, dark energy. They're all stand-in props for not understanding what general relativity is and what the results of general relativity.
To look at what we don't understand, because there are bits of Einstein's theory getting Mach's principle in there in a proper deep way that he never fully resolved, but which are actually there in the theory, I claim. It's just that we have to understand things, and that means going back and looking at data, really the deep underlying.
And I think Einstein actually did understand it, but every time he talked about it, nobody understood what he was saying. But he actually did talk about it and wrote about it in his papers. It's called the variable speed of light, is what it is.
Physics.
Let's start there. Let's start with Mach's principle, M-A-C-H, not M-O-C-A-K, which a lot of people like to mock other people. Who was Mach? What did he do? And why was his 1800s era kind of thinking and almost philosophy rather than hardcore quantitative physics? Why was that so important? Why was that so influential to Einstein himself?
The thing with relativity is that space and time are a relational structure between things. And in looking at that relational structure, we've got to look at, well, what is the relational structure between us and the whole universe? Newton thought about Mach's principle in the sense that he imagined, well, if I have a rotating bucket of water, then the water will creep up the sides of the bucket. So there is an absolute frame of rest. Mach in the 19th century said, well, actually, it's really a relation between the fixed stars and the bucket. So if I could rotate the whole universe, then I would get the same thing. So the thing is that there is a relationship between inertial frames. How do we define the distant parts of our universe, infinity, and trying to understand what is the relationship between us and the whole universe? What are the averages? So Einstein thought that he was hoping to find that relational structure in general relativity, but there are solutions of his theory, such as Gödel's universe, which rotates about every point, which are really unphysical, which should be outlawed by some deeper principle. And that's what I'm claiming to do with what I call the cosmological equivalence principle. There are certain solutions of Einstein's theory that should not be allowed by its fundamental principles if we deepen those principles and try and understand things better. That's Mach's principle and why I'm trying to do things. And I believe it's there in the relativity. Einstein just